Today, we are going to talk about how to solve three variable systems using substitution and elimination. Now, substitution and elimination is something that you should remember from Algebra 1, but we're going to kind of go over it a little bit in the beginning. So let's first look at substitution. So when I see a problem and there are variables, so in this case, x and y, and they're by themselves. So notice I have a single x and a single y. Most likely, this problem will be better solved using substitution because you can easily get one of these equations by itself. So by that, I mean, I'm going to come in and I'm going to take the second equation. It doesn't matter in this case if you're solving for x or y, but you want to get one of the variables by themselves. So I'm going to go ahead and add y to both sides. And so I'm going to get x equals y plus 1. And so what we're going to do with that is we are going to substitute it into the other equation. So I'm going to take everything that x is equal to, so in this case, y plus 1, and I'm going to substitute it in where I see x in the other problem. So I'm going to go ahead and do that. Everything else will stay the same. So I'm going to have 2, and where x is, I'm going to plug in y plus 1. I'm going to leave the 3y alone, and it's going to be equal to 27. Now, the goal of this process is that you now have an equation with only one variable. So in this case, it's all in terms of y. So we're going to go ahead and distribute and combine like terms and try to solve for y. So I'm going to start by distributing this 2, and I'm going to have 2y plus 2 plus 3y is equal to 27. And that's going to give me 5y plus 2 is equal to 27. If I subtract 2 from both sides, I'm going to get 5y is equal to 25. And if I divide by 5, I'm going to get y is equal to 5. Now, that is one part of my solution. When you're solving a system, you want to go in and find all of the variables. So this case, I have y. I still need to find x. It doesn't matter which equation you plug into. Both of them are going to give you the same value for x. So truthfully, I try to pick the easier one. So in this case, x minus y equals 1 seems to be a lot easier. You can even substitute into the equation where you've already solved for x. So I'm just going to go in and plug in 5 plus 1 because 5 is what I got for y. And so this tells me that x is equal to 6. Now, how we answer these in the end. Whenever you are graphing an inequality, when you are graphing a system of equations, you are looking for where they intersect. And typically that is an xy coordinate. So for two variables, how we write it is as an ordered triplet or an ordered pair. So I'm going to have 6, 5. And so that is going to be my solution. And it's always going to be in alpha order. So when you look at these and you don't have any word problem settings whatsoever, this is how we're going to write our answer. Because again, if I were to draw these as linear equations, the solution is going to be the intersection of where these two lines meet, which is why we use an ordered pair. Now let's go ahead and try elimination. For elimination, you are trying to get rid of either x or y. It doesn't matter which one you pick, but the way that we do that is you want them to be the same number, but you want them to have different signs. So I'm going to go ahead and just get rid of the x's. I could very easily get rid of the y's, but I think the y's will get to be a little bit bigger, and I'm going to try to avoid that. So if I look at the x's currently, I have a 2 and a 3. Now, you want to multiply these by something so that they end up being the same number with different signs. So I'm going to go ahead and make them both become a 6. So I'm going to have 2, and I'm going to multiply that by positive 3 on both sides. And if I want them to have a different sign from each other, one of them is going to have to be negative. So in this case, I'm just going to make -2 on the bottom. Now, how you choose this is completely up to you. I didn't have to pick 6. I could have went all the way up to 12 if I really wanted to. But I do say try to keep your numbers as small as possible. So now let's go in and let's distribute these values. I'm going to have 6x plus 12y equals to -30 if I multiply all of those first equations by 3, or first terms by 3. Same thing, -6x minus 6y is equal to +6, because if I take a negative times a negative, I'm going to get a positive. Now, with elimination, it's also referred to as linear combination. So what that means is we're basically going to come in and we are going to combine vertically. So all of the x's are going to get combined with x's, all of the y's with y's, the constants with constants. So hopefully, after you've done your round of multiplying things by other values, you should get something that gets eliminated. In this case, the -6 and the +6 will cancel each other out, and I will be left with 12 minus 6 is 6y, and -30 plus 6 is -24. And so we solve for y like normal. I'm going to divide by 6, divide by 6, y equals to -4. Again, anytime you have one of these system problems, you can't just stop there. So I'm going to take that y equals -4 and I'm going to substitute it in. Typically, I suggest choosing one of the original problems just because the numbers will stay a little bit smaller. So 4, -4 equals -10. So all I did was take the first equation, and where there was a y value, I substituted in -4. So I'm going to have 2x minus 16 equals to -10. I'm going to add 16, 2x is equal to +6, divide by 2, x is equal to 3. Now remember again, just getting x and y in this case is not your final answer. You're always going to come in and write it, if it's two variables, as an ordered pair. So this solution would be 3, -4. And again, we always go in alpha order. So X, Y, Z, A, B, C. Whatever letters you're looking at, just put them in alphabetical order. So that's kind of a small review of what you should have talked about in Algebra 1. Now let's kind of take this another level higher and look at 3 variable systems. Now, a lot of these that you see in Algebra 2 are not terribly hard. You just have to kind of know how to approach them. So the first thing I'm going to do is I'm going to look at example 1. And this is a nice one. We're starting off easy. For the most part, with substitution problems in Algebra 2 Advanced, you're kind of working your way from the bottom to the top. So in this case, I see at the very bottom, I already have one answer that I need, and that is that z is equal to 4. Wonderful. I'm going to take that value and I'm going to plug it in everywhere else in the equation because it might make my life a little bit easier. So just to kind of take that, I'm going to have x plus y plus 4 is equal to 12, and I'm going to have y plus 4 is equal to 7. And usually when you do this, you'll find that you can solve for another variable. So in this case, I can come in and I can subtract 4 from both sides, and I can have x is equal, or y is equal, y is equal to +3. So there is another value that I need. I now know z, I now know y, and so I can take both of those and I can plug them into the first equation. So let's go back to a pen. X plus 3, because that's what the y value is, plus 4, because that's what the z value is, equals to 12. So that gives me x plus 7 is equal to 12. And if I subtract 7 from both sides, x is equal to 5. Now, just like what we did with the solutions to 2-variable systems, you will do something similar for 3-variable. This time it's going to be referred to as an ordered triplet. So that means I'm going to come in and I'm going to write x, comma, y, comma, z. And again, you are going in alphabetical order for these. And if you don't have context, meaning it is just a number problem, you have to write it as an ordered triplet. Do not forget. Otherwise, you will lose points if your final answer is not written in this way. So let's go and let's try another one. Now, this one does require a little bit of solving to get us to that z value, but I'm going to start first by going in and dividing both sides by 3. And that's going to give me z is equal to -1. And that's one of the answers that I need for my ordered triplet. Again, it's kind of like you're working your way up. I'm going to go ahead and take that second equation, and I'm going to end up with 2y minus. Now, I'm plugging in z. Here is where I want you to be really, really careful, because you have to remember if you have 2 negatives, that is going to turn into a positive value. So I'm going to take that -1, leave it in parentheses just so that I don't forget, because that is going to turn into 2y plus 1 equals 7. I'm going to minus 1. I'm going to minus 1. 2y equals to 6. Divide by 2. Divide by 2. Y is equal to 3. And again, once I get another piece of my puzzle, I kind of work my way up to the next equation. And in this case, we're going to have 2x minus, my y value was 3, so I'm going to have a 3 there, plus 3, my z value was -1, equals to -2. So now that I have this, let's do a little bit of simplifying. 2x minus 3 equals to -2. 2x minus 6 is equal to -2. Now I can go in and add 6 to both sides. 2x is equal to 4. Divide by 2, divide by 2, x is equal to 2. So I have all 3 things that I need. All I have to do is come in and take my 3 values and write them as an ordered triplet. So 2, 3, -1. Now, both of these methods utilize substitution. Let's go ahead and talk about what this would look like if we were going to do substitution where you're not necessarily solving from the bottom to the top. So if I look at example 3, the first thing that I kind of want you to notice is try to pay attention to things that look the same. So in this case, when I look at 3, I see that I have an x plus y that are completely by themselves. So 1x and 1y. And I also see that I have another 1x and 1y. And I can kind of use that to my advantage, because what I'm going to do is I'm going to go ahead and say in this bottom equation that if I add z to both sides, x plus y is equal to z. So anywhere I see x plus y, I can replace it with a z variable. So where it gets to be a little confusing is because it's going to kind of look the same. I'm going to take this first equation, and I can see very clearly there's an x plus y in there. So instead of having that x plus y there, I'm going to substitute it with this single positive z. So that is going to turn into, and I'm going to try to break this down step by step. It originally started as x plus y plus z equals 24, but instead of having x plus y there, since I know that that whole statement is equal to z, I'm just going to have z plus z is equal to 24, which is 2z is equal to 24, divide by 2, divide by 2, z is equal to 12. And that's going to be my first value that I have. Now, generally after this, my usual recommendation is to go in and fill in some values with that first problem that you have. So I'm going to kind of take the same thing. I'm basically going to remake the whole system, but instead of having the z, I'm going to replace everything with 12. X plus y plus 12 is equal to 24. 5x plus 3y plus 12 is equal to 56. And then x plus y minus 12 is equal to 0. Now, a couple of things we can do now is we can kind of approach this with substitution or with elimination in mind. Now that I have some problems where it's just x and y. So a couple of things. When you look at these first equation and this last equation, they basically are the same thing. If I were to move those 12s over to the other side, I'm going to get x plus y equals to 12. So whether you're trying to simplify the first one or the last one, you get the same thing either way. And then if I simplify the second equation, that is going to turn into 5x plus 3y is equal to 44, because 56 minus 12 is going to give me 44. This makes it so that we can do this using elimination, and that's going to make it a little bit easier. So I have an x, I have a y. Again, it doesn't matter which one you eliminate. I'm going to go ahead and get rid of the x's. I already see that there's a 5x there, so I'm just going to come in on the top, and everything's going to get multiplied by negative 5. So I'm going to have negative 5x minus 5y is equal to negative 60. And if I come in and combine these two things together, remember, it's like you are doing a linear combination, the x's with the x's, the y's with the y's, the numbers with the numbers. I can go in, get rid of the 5x and the negative 5x. Negative 5 plus 3 is negative 2y, and negative 60 plus 4 is negative 16. If I divide by negative 2, divide by negative 2, I'm going to get y equals to positive 8. So 2 things I've already gotten taken care of. I found my z. I found my y. The last thing I need to find is my x. Again, you can kind of plug into any of the equations you've kind of messed with already. We already know that x plus y has to equal to 12. So I'm just going to do x plus 8 is equal to 12 because we said y is equal to 8. And if I minus 8, I'm going to get x is equal to 4. And so in the end, my final answer is going to be 4, 8, 12. And that will be my solution to the 3 variable system using a little bit of substitution and elimination. One thing that you're going to find as we work through these problems is there are multiple ways to get to your final answer. Yes, you have to do your algebraic work correctly, but you may solve for x first instead of y, or you may easily find z and then decide that you want to do elimination instead of substitution. It is completely up to you as long as you are not breaking any rules of math. So all of these are just word problems, which is why, or just algebraic systems of equations. So that's why we require you to have an ordered triplet. The next 2 we're going to look at are word problems, and those are going to require some word answers. So the first thing, we have a problem that is asking us to, it's giving us a bunch of information. Sum of 3 numbers is negative 4. The second number decreased by the third is equal to the first. The sum of the first and second is negative 5. Write a system of equations to represent the following situation and find the product of the 3 numbers. So the first thing we're always going to do is we're going to come in and define some variables. I'm going to call x my first number, y, my second number, and z, my third number. And so I kind of do this by highlighting my big pieces of information. I know the sum of three numbers is -4. I know that the second number decreased by the third is equal to the first. And I know the sum of the first and the second number is -5. Typically, for every single variable that you have, you're going to have an equation. Not necessarily like x equals y equals z equals, but if I have three variables, I should have three equations. So I'm going to start with the first one because that one seems the easiest. The sum of three numbers is -4. Typically, is kind of like your equal to point when you're writing these equations. And in our case, sum is going to be addition. So if I take all three numbers and I add them together, the sum of the three numbers, I know that's going to be equal to -4. Then we are going to go in and look at the second one. So the second number decreased by the third is equal to the first. So is kind of like my equal to point. So the second number is y, and we're saying we're decreasing it by the third number, and it's equal to the first. And for my last equation, the sum of the first and second number is 5, or -5. So the sum of the first and the second is -5. So here is my system of equations. Now we're going to go ahead and we are going to plug in our values. Now, how you choose to approach this is completely up to you. I'm going to go ahead and since my second equation is already in terms of x equals, that means everywhere I see x, I can substitute in y minus z. So I'm going to go ahead and substitute in that y minus z to the first equation. So if I do that, I'm going to have y minus z plus y plus z is equal to -4. Again, the only thing I changed in that equation, the first one, is instead of having x, I put y minus z. Now, this is nice because in order for me to simplify this, I can say that -z and +z cancel each other out, and I end up with 2y equals to -4, divide by 2, divide by 2, y is equal to -2. So that's one piece of the puzzle. Then I'm going to go in, and since I know what y equals to, I'm going to take that last equation, and I'm going to have x plus -2, which is the same thing as x minus 2, is equal to -5. I'm going to add 2, x should be equal to -3. So I have two of the three numbers that I'm supposed to have. Now I can go in and I can take those two numbers and plug them really in anywhere in order to find my z. I'm just going to go ahead and plug them into the first equation. And I'm going to have -3, because that's what x is, plus -2, so the same thing as -2, that's what y is, plus z is equal to -4. So I have -5 plus z is equal to -4. I'm going to add 5, z should be equal to +1. And in this case, when you have word problems, you have to list these out like word answers. So I'm going to say the first number is -3. Second number is -2. And the third number is +1. So make sure when you're answering any word problems, you're taking it back to the context of the question. Let's go ahead and let's try our last one. So the triangle has a perimeter of 65 feet. What are the lengths of sides L, M, and N? So perimeter is all the way around. So I know if I add all of these sides together, I'm going to get 65 feet. So if I go in and I look at my first equation, I can say L plus M plus N is equal to 65. Now, the really, really nice thing about what we're currently looking at is we can kind of use what they gave us to substitute in and find some different equations. So the first thing is they told us L is equal to 1/3 M, and they said N is equal to L plus M minus 15. And both of these equations are almost all in terms of M, but what I'm going to do for this last one, I'm going to kind of change it a little bit. I'm going to say N is equal to 1/3 M, because that's the same thing as L, if you can look at the one right above it. L is equal to 1/3 M. And I'm going to just fill that in. So 1/3 M plus M minus 15. And so now I have L equals and N equals, and they're all with the same variable. So I'm going to substitute into the first equation. So L is 1/3 M. So I'm going to have 1/3 M. M is just M itself, so I'm going to leave that alone. N is 1/3 M plus M minus 15. And we know all together this is 65. So now I kind of have to combine some things. So the first thing I will say, I'm going to go ahead and move that 15 over and just kind of get that out of the way. So I'm going to have, let's combine the whole number M's as well. 2M, because there's two whole ones. And I have 2/3 M, and that's going to be equal to 80 if I move that 15 over by adding it to both sides. Now, here's a little trick. If you have fractions and you don't want to deal with fractions, because none of us do, go in and multiply by the denominator. I'm going to take the whole thing, both sides, every single term, and I'm going to multiply them by 3. So that's going to give me 6M plus 2M, because that's going to get rid of the denominator, is equal to 240. Because 8 times 3 is 24. You add in a 0, 240. So I'm going to have 8M is equal to 240. Divide by 8. Divide by 8. M is equal to 30. So that's one of my side lengths. Now I just have to take that number that I have and substitute it in everywhere else. So for L, I can say 1/3 of 30 is equal to 10. And for N, I can say 1/3 of 30 plus 30 minus 15 is equal to 10 plus 30 minus 15, which should be equal to 25. And so I can go in and say the side lengths are L is equal to 10 feet, M is equal to 30 feet, and N is equal to 25 feet. We will require, if you know units, that you include them. So notice I took feet from the question and I wrote it with all of my answers for the different side lengths of the triangle.